We're going to take a look at the series from 1 to infinity of the sine of n. Now this is equal to sine of 1 plus sine of 2 plus sine of 3 plus sine of 4 and so on, where 1, 2, 3, and 4 are, and all n are measured in radians. And we're going to use the test for divergence. What is test for divergence? Well, when we have a series and if the limit as n goes to infinity of an is not 0, and that means either it's undefined or it's finite value other than 0, then our series diverges. That's what test for divergence says. Now what it doesn't say is, let me summarize that here. So the test does not say that if the limit is 0, so limit n goes to infinity, an does equal to 0, then the series converges. That is not true. Some series may converge, some may diverge. The test is simply inconclusive when this limit is 0, but when it's not 0, we're guaranteed 100% that the series will diverge. So returning to our series that's from 1 to infinity of sine of n, we have to evaluate the limit as n goes to infinity of sine of n. But this limit clearly does not exist. And that's because all we have to do is look at the graph of y equal to sine of x. This is a continuous function for x greater than or equal to 0 or greater than or equal to 1. This graph looks something like this. So it's a wave like this, and as we put in integral positive integer values of x into sine of x, we do not get values that are heading toward the same place, which is what limit has to have. So the limit as n goes to infinity of sine of n does not exist, and does not exist means obviously that that is not equal to 0. There is nothing that it goes to, so it doesn't go to 0, and that means we can now use test for divergence to conclude that the series from 1 to infinity of sine of n diverges by the test for divergence. For more videos, visit www.mathprepvideos.com.